how do we make use of laws of logarithms in questions or in calculations? This lesson is aimed at giving you different approaches on how you can apply the laws of logarithms in calculations. The knowledge that you need to have for you to understand this lesson better is the laws of logarithms themselves, to be able to state them. Number two, you need to have the laws of indices, and you need to know how to convert between index notations and logarithm notations. Don't worry, I have provided the links to those lessons in my description, so you can check if you need to learn better those concepts. So we are going to learn by use of questions, and our first question is, given that logarithm of 2 to base 10 equals to 0.3010 and logarithm of 3 to base 10 equals to 0.4771, evaluate logarithm of 6 to base 10. Solution. Logarithm of 6 to base 10 is the same as logarithm of 2 multiplied by 3 to base 10. If you look at this keenly, you notice that we have only expressed 6 in terms of its factors, of which we are given the logarithms for those factors. That is, 2 times 3 gives us 6. Now, according to the law that states that logarithm of xy to base a equals to logarithm of x base a plus logarithm of y base a, we can write logarithm of 2 times 3 to base 10 as logarithm of 2 to base 10 plus logarithm of 3 to base 10. And therefore we have logarithm of 2 is given and logarithm of 3 is also given. So we substitute with 0.3010 plus 0.4771, and the sum is 0.7781, which is the answer that we were looking for. Question 2. Given that logarithm of 2 to base 10 is equal to 0.3010 and logarithm of 3 to base 10 is equal to 0.4771, evaluate logarithm of 18 to base 10. Solution. Logarithm of 18 to base 10 can be expressed as logarithm of 2 times 9 to base 10. 2 times 9 is the same as 18. And further we can write 2 times 9 as 2 times 3 squared. So we can write logarithm of 18 to base 10 as logarithm of 2 times 3 squared to base 10. Our interest here is having inside the brackets factors for which the logarithm is provided for in question. So now, according to the law of logarithms that state that logarithm of xy to base a equals to logarithm of x to base a plus logarithm of y to base a, we can write logarithm of 2 times 3 squared to base 10 as logarithm of 2 to base 10 plus logarithm of 3 squared to base 10. Again, according to the third law of logarithms that states that logarithm of x power n to base a equals to n multiplied by logarithm of x to base a we can write logarithm of 3 squared to base 10 as 2 multiplied by the logarithm of 3 to base 10. So our overall equation is logarithm of 2 times 3 squared to base 10 equals to logarithm of 2 to base 10 plus 2 multiplied by logarithm of 3 to base 10. Now that we have been given the logarithm of 2 and logarithm of 3 in the question, we substitute for this and we have 0.3010 instead of logarithm of 2 to base 10 plus 2 into logarithm of 3 to base 10, which is 0.4771. Now simplifying this, we end up having 1.2552, which is the answer that we have been looking for. Question 3. Simplify logarithm of 8 to base 2 minus logarithm of 4 to base 2. Solution. According to the law of logarithm that states that logarithm of x over y to base a equals to logarithm of x to base a minus logarithm of y to base a, we can write logarithm of 8 to base 2 minus logarithm of 4 to base 2 as logarithm of 8 over 4 to base 2. 8 over 4 is 2, so we can write logarithm of 2 to base 2. Now this can further be simplified, and we have to use the law of logarithms that states that logarithm of a to the same base a equals to 1, or in general, any logarithm of a number to the same base is 1. So it implies that logarithm of 2 to base 2 is 1. And so that means that logarithm of 8 to base 2 minus logarithm of 4 to base 2 equals to 1. In other words, the answer to our question is 1. Alternatively, we can pick it from where we have logarithm of 2 to base 2 and use another method to also solve the sum. So we could have logarithm of 2 to base 2 equals to x. In other words, let logarithm of 2 to base 2 be equal to x. So we want to know what is x. Now, let us express logarithm of 2 to base 2 equals to x in index notation. So this is 2 raised to power x equals to 2. Now that 2 is the same as 2 power 1, then we can write 2 power x equals to 2 power 1. Since the bases are the same, then it implies that the powers must also be the same, and that is x equals to 1. So the answer to our question is logarithm of 8 to base 2 minus logarithm of 4 to base 2 equals to 1. Question 4. Solve for x given that logarithm of 243 to base of x equals to 5. Solution. Let us convert logarithm of 243 to base x equals to 5 to index notation. That is, x power 5 equals to 243. We can write 243 in terms of its factors, and that is 3 power 5. So our equation becomes x power 5 equals to 3 power 5. Since the powers are the same, it means that the bases must also be the same. And that is to say that x equals to 3, which is the answer now. Question 5. Solve for x given that logarithm of 5 plus logarithm of x equals to logarithm of 15. Solution. Using the law that states logarithm of xy to base a equals to logarithm of x to base a plus logarithm of y to base a, we can write logarithm of 5 times x equals to logarithm of 15. So we can now drop the logarithms because they are common on both sides and have 5x equals to 15. Then dividing both sides by 5, x becomes 3. Question 6. Find y if logarithm of 5 to base 2 plus logarithm of y to base 2 equals to logarithm of 15 to base 2 plus 1. Solution. We know that logarithm of any number to base itself equals to 1. So it means that 1 can be expressed in terms of logarithm, and this is logarithm of 2 to base 2. We are expressing in terms of logarithm to base 2 because the rest have base 2. So we want to make sure that everything takes the same base. So logarithm of 5 to base 2 plus logarithm of y to base 2 equals to logarithm of 15 to base 2 plus, instead of 1, we now substitute with logarithm of 2 to base 2. Then now using the law of logarithms that states that logarithm of any product is the same as the sum of the individual logarithms. That is, logarithm of xy equals to logarithm of x plus logarithm of y, everything to the same base. So on the left hand side of our equation, we have logarithm of 5 plus logarithm of y. This is the same as logarithm of 5 times y. And on the right hand side, we have logarithm of 15 plus logarithm of 2. This is the same as logarithm of 15 times 2. This can be written as logarithm to base 2 of 5y equals to logarithm of 15 times 2 to base 2. 15 times 2 is 30, so we can write logarithm of 5y equals to logarithm of 30, everything to base 2. So 5y equals to 30. That means we have to drop the logarithms because they are the same on both sides. So we write 5y equals to 30. Then for us to get the value of y, we divide both sides by 5, and so y equals to 6. That is the answer we have been looking for. Question 7. Simplify logarithm of 625 plus logarithm of 125 all over logarithm of 25. Solution. 625, 125, and 25 can all be expressed in terms of their prime factors, and fortunately the prime factor is 5. So 625 is the same as 5 power 4, 125 is the same as 5 power 3, and 25 is the same as 5 squared. So let us substitute with the factors, and we have logarithm of 5 power 4 plus logarithm of 5 power 3 all over logarithm of 5 squared. According to the law that states that logarithm of x power n to base a equals to logarithm of x to base a multiplied by n, we can write this as logarithm of 5 power 4 being equal to 4 multiplied by the logarithm of 5, then logarithm of 5 power 3 equals to 3 multiplied by logarithm of 5, and logarithm of 5 squared equals to 2 multiplied by the logarithm of 5. So let us substitute all these in our earlier expression, and this is 4 multiplied by logarithm of 5 plus 3 multiplied by the logarithm of 5 all over 2 multiplied by the logarithm of 5. On the numerator, we have 4 multiplied by logarithm of 5 plus 3 logarithm of 5. So we can simplify this and have 4 plus 3, which is 7. Then we have 7 multiplied by logarithm of 5. Then divided by 2 multiplied by the logarithm of 5. Since the logarithm 5 is common on both the numerator and the denominator, we can cancel out to 1, so that we remain with 7 over 2, which can also be written as 3.5. So that is the simplified form of the given expression. Question 8. Solve logarithm of 81 to base 3. Solution. Let the logarithm of 81 to base 3 be equal to x. So we need to convert this to index notation, and this is 3 raised to power x equals to 81. 81 can be written in terms of base 3 as 3 power 4. So 3 power x equals to 3 power 4. Now that the bases are the same, it means that the powers must also be the same, and that is x equals to 4. So logarithm of 81 to base 3 equals to 4. Question 9. Solve logarithm of 5 to base 3. Solution. We need to let logarithm of 5 to base 3 be equal to x. Then we convert to index notation, which becomes 3 power x equals to 5. Now the question is, can 5 be expressed to base of 3? No. So if this is not possible, then what do we need to do? We simply need to introduce logarithm on both sides, so that we have logarithm of 3 power x equals to the logarithm of 5. According to this law that states that logarithm of x power n to base a equals to n multiplied by the logarithm of x to base a, we can write logarithm of 3 power x as x multiplied by the logarithm of 3. So we have x multiplied by the logarithm of 3 being equal to the logarithm of 5. So we need now to divide both sides by logarithm of 3 so that we make x the subject. So x equals to the logarithm of 5 divided by the logarithm of 3. Using our calculators, we can evaluate this and we get our answer as 1.465. That is correct to 4 significant figures. Therefore, logarithm of 5 to base 3 equals to 1.465, correct to 4 significant figures. You can now practice with the following questions. Thank you for watching. If you have any question, please put it in the comment section below and I'll get back to you for response. Goodbye.